Hello student of class 9, let's continue our chapter gravitation, and today we are going to discuss very important law which is given by Sir Isaac Newton after writing the three laws. So this law is called universal law of gravitation, or we can say it is Newton's universal law of gravitation. This law is important because this law is applicable in our whole universe. So in our whole universe, if you go anywhere, then this law will work. According to this law, every object in the universe attract each other with a force which is proportional product of their masses and inversely proportional to the square of the distance between them. And the force is along the line joining the center of two objects. So student, according to this law, every two objects in this universe attract each other with a force of attraction. And these force of attraction depend on two factors. One is the product of the mass of two objects and the distance between the two objects. If the product of the mass increases, then the force of attraction also increases. If the product of the mass is decreases, then force of attraction also decreases. So you can say the force of attraction is directly proportional to the product of the mass. And also the force of attraction is dependent on another factor, which is distance between the two objects. If the distance between the two objects increases, then the force of attraction is decreases, and if the distance between the two objects is decreases, then the force of attraction increases. So you can say force of attraction is also depend on the distance between the two objects, but it is inversely proportional. So you can say every two objects in this universe attract each other with a force and which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So this law also we can prove this. For proof, we have taken two objects. One object is A, another object is B, and between the two objects, center to center distance is D. And the force whatever exerting on each other, this force is suppose F. According to the universal law of gravitation, the force of attraction between two objects is directly proportional to the product of their masses. So the first object A mass suppose capital M, and second object B mass is suppose small m. Then product of their mass means M, capital M into small m. So you can see F is directly proportional capital M into small m in equation number 10.1. This is the first factor, and the second factor, we know that the force of attraction between two objects is inversely proportional to the square. So in equation number 10.2 you can see F is inversely proportional to the square of the distance. So by equation 10.1 and 10.2, by combining, we get F is directly proportional to multiple of the equation 10.1 and 10.2. That means m into 1 by d square. So if we want to remove this proportional sign and if we want to put equal sign, then we must take a constant. So you can see 10.4 equation, instead of proportional sign given here equal sign, so constant taken here, and this constant is capital G, and G is here called constant of proportionality and is also called the universal gravitational constant. Always remember this G value is fixed, that is 6.637 into 10 to the power minus 10 to the power minus 11 Newton meter square per kg square. So this equation 10.4 is the formula of finding the force of attraction between the two objects. So if you want to find out the force of attraction between two objects, then you must know the object mass and the distance between them. Then you can apply this formula and you can find the force of attraction. So by simplifying this formula also, you can write down the formula of capital G. If we cross multiply and Solve G, then we'll get Fd squared by capital M into small m. So this is the formula of capital G, means universal gravitational constant. We know that there exists a force of attraction between any two objects, so we can find out any force of attraction between two objects if we know the mass of the two objects and the distance between the two objects.